Hey everyone, and welcome to the Deep Dive. Ready to dive deep into some fascinating science?
Always ready. Let's do it.
Today we're going to be exploring the life and work of Louis Néel, a physicist who, well, basically revolutionized how we understand magnetism.
A pretty big deal.
Yeah, seriously big. And the really cool thing is that his work has had such a huge impact on techs, even stuff we use every single day.
Oh, absolutely. In fact, the device you're listening to this on right now, it might not even exist if it weren't for Néel's discoveries.
It's true. So we've got his biography here. We're going to break it all down for you.
Should be fun.
All right, let's start with the basics. Néel was born in Lyon, France. And get this, his education is basically a list of, like, the most prestigious institutions you can think of.
Oh, yeah.
I'm talking Lycée du Parc, École Normale Supérieure, and he even snagged his Doctor of Science degree from the University of Strasbourg.
Wow. Yeah, talk about an impressive academic journey. That kind of background in the sciences was crucial for the groundbreaking research he'd go on to do.
Oh, and his research. It definitely shook things up in the world of physics. Okay, you ready for this? It's called antiferromagnetism.
Antiferromagnetism.
So you've probably heard of ferromagnetism, right? Like the regular magnets we see all the time.
Right.
Well, antiferromagnetism is a whole different ballgame.
Yeah, completely different. Imagine this. Each atom in a material is like a tiny little compass needle.
Okay, I'm picturing it.
Now, in ferromagnetic materials, all those little needles are pointing in the same direction.
Creating a strong magnetic field, right?
Exactly. But in antiferromagnetic materials, those needles, they line up in opposite directions. So they basically cancel each other out.
So from the outside, it doesn't even look magnetic.
Nope. It's like this hidden magnetic dance happening at the atomic level.
That's so wild. But it's not just some weird scientific quirk, is it?
No.
I mean, this discovery totally changed how scientists thought about magnetism back then.
It really did. It forced them to re-examine all their assumptions about how magnetism worked. It opened up a whole new world of research. And then, of course, you've got the Néel temperature, named after him.
Néel temperature.
Above that specific temperature, all that delicate alignment of the atomic needles gets, scrambled by thermal energy, and poof, the antiferromagnetism vanishes.
But below that temperature.
That's where the magic happens.
Now, you mentioned that this has implications for technology. What kind of stuff are we talking about here?
Well, think about spintronics.
Spintronics, huh?
Yeah, it's a really cool field that's all about using the spin of electrons, not just their charge to carry information. And you know what? Antiferromagnetic materials, they're turning out to be super promising for spintronics. It could lead to some really amazing advancements in electronics.
So we could have even faster and more efficient devices thanks to this discovery. That's pretty amazing.
It is. And guess what? Néel didn't stop there. Later on, he goes on to discover another kind of magnetism. We call it ferrimagnetism. It's kind of like a more complex dance of those tiny compass needles we were talking about.
Okay, now I'm really intrigued. Ferrimagnetism, huh? Break it down for us. What is it, and why is it so important?
So in ferrimagnetism, you still have those little compass needles pointing in opposite directions, just like in antiferromagnetism. But here's the twist. The strength of those needles isn't quite equal.
Oh, interesting.
Yeah, so they don't completely cancel each other out. The material actually ends up having a net magnetic moment, so it is magnetic overall. And this is the super important part. This property makes ferromagnetic materials perfect for, you guessed it, computer memory.
Wait, hold on. Are you saying that how our computers store information is directly related to this?
You got it. Before ferromagnetic materials, computer memory was, well, it was bulky and slow and not nearly as reliable as it is today.
That's incredible.
It is. And because of Néel's discoveries, we could use these ferrimagnetic materials in things like hard drives and magnetic tapes. It's like we suddenly leaped forward in how much data we could store and how efficiently we could do it.
So all those gigabytes and even terabytes of data we can store on our computers,
Yeah.
that's partially thanks to Néel.
Exactly. I mean, think about it. The fact that you can store and access all that information, that's a pretty big deal, and it's partly because of his work.
That's wild. It really shows how some of the most fundamental research can end up having such a tangible impact on our lives.
It's pretty remarkable. And you know what? Néel didn't just focus on those tiny atomic magnets. He made some really significant contributions to geomagnetism, too.
Geomagnetism?
That's right. You know, the study of Earth's magnetic field. Remember those tiny compass needles we were picturing earlier?
Yeah.
Well, Néel figured out why some rocks have this really weak magnetic signature.
Okay, now I'm curious. Why is that so significant?
Because it gave us a window into Earth's past. Well, by looking at the weak magnetism in those rocks, scientists can actually reconstruct the history of Earth's magnetic field. It's like we have a geological time machine now. It gives us all these clues about continental drift and volcanic activity, even past climate change.
So Néel's work connected these tiny compass needles to the massive magnetic field of our entire planet.
Exactly. Pretty amazing, isn't it?
It really is.
And here's another thing. Néel wasn't just some lone genius hidden away in his lab. He was a real builder of scientific communities. In fact, he was the driving force behind creating something called the Polygon Scientifique in Grenoble.
Polygon Scientifique. What is that exactly?
Well, it's basically a giant science and technology park. It's home to tons of research institutions and innovative companies.
That's awesome.
It is, and it's all because of Néel. He understood that collaboration and resources were key for scientific advancement, and by fostering that environment, he created a lasting legacy that's still benefiting the scientific world today.
So not only did he make all these amazing discoveries himself, but he helped create a space where others could do the same. That's truly remarkable.
Totally agree. And speaking of remarkable, can we talk about the recognition Néel received for his work? We're talking a long list of awards and honors here. And of course, the ultimate prize, the Nobel Prize in Physics, which he shared with Anna Solvén in 1970.
The Nobel Prize. Yeah, that's definitely a big deal in the science world. It's like confirmation that your work is groundbreaking.
It is. The Nobel Prize is like, you know, the Mount Everest of scientific achievement. It really proves just how huge of an impact Néel had on the world of physics.
I'm guessing the Nobel Prize wasn't the only award he got for his work, right?
Oh, definitely not. He received a ton of other really prestigious awards, too, like the Hughes Prize, the Hollick Prize, the Three Physicists Prize. They all recognize different parts of his contributions to the field of magnetism.
Wow.
Oh, and here's where it gets a little unexpected. Alongside all those incredible scientific awards, Néel also received a bunch of military distinctions.
Military honors. Now, that is a surprise. What did he do to earn those?
Well, during World War II, Néel actually used his knowledge of magnetism to help protect warships from a very serious threat: magnetic mines.
Magnetic mines? I've never even heard of those.
Well, they were a big problem back then. They were designed to explode when they sensed the magnetic signature of a ship passing by. Pretty clever, huh? But Néel was even cleverer. He used his expertise to develop techniques for degaussing ships. Basically, that means neutralizing their magnetic field, making them undetectable by the mines.
So he was using his scientific brilliance to protect lives and help win the war.
Exactly. It's really a testament to his ingenuity and how he could apply his knowledge in such a practical way to make a real difference in the world.
Wow, this is amazing. Who knew that a fascination with magnetism could lead to all of this?
It's pretty incredible. And it just goes to show you never know where scientific curiosity might take you, you know? It really is remarkable. It makes you realize just how connected science really is when you look at a life like Néel's. You know, who would have guessed that studying magnetism at the tiniest level, like atoms, could end up helping us understand the history of our whole planet?
It's like this chain reaction, right? One discovery leads to another, and before you know it, you've got this ripple effect touching everything. Science, tech.
Exactly. And it reminds us that science isn't always like a straight line from point A to point B. Sometimes the biggest breakthroughs come from the most unexpected discoveries.
You know, speaking of unexpected, I've been thinking about those military distinctions Néel received.
Oh, right.
It's not every day you hear about a physicist getting honors for what they did during wartime. Can you tell us a bit more about Néel's work in World War II?
Of course. So during the war, magnetic mines were a major threat to naval ships.
Oh, wow.
Yeah, they were designed to detonate when they detected the magnetic field of a ship passing by.
Well, so Néel used his knowledge of magnetism to, well, basically outsmart those mines. He developed ways to degauss ships.
Dicing.
It means neutralizing the ship's magnetic field, making it invisible to the mines.
So he was using his scientific expertise to protect lives and even help win the war. That's incredible.
It really is. And it shows how resourceful he was, how he could use his knowledge to solve a really pressing problem.
It all started with his fascination with magnetism. You just never know where a scientific passion will lead you.
Exactly. I think Neil's story really emphasizes how important basic research is. Even research that seems really abstract can lead to innovations that change the world.
That's a great point. We've talked a lot about his groundbreaking discoveries, but what about Neil himself? What kind of person was he?
Well, from everything I've read, he was known for being incredibly intelligent and dedicated to his work.
That makes sense.
Oh, and he was also a huge believer in collaboration. He wasn't just a brilliant scientist, he was a mentor, a leader. He really inspired those around him to push the boundaries of science. Sounds like he had a real love for science, a passion that he wanted to share with everyone.
Absolutely. You can see that passion in all his work. He wasn't just interested in solving equations. He wanted to understand the very forces that shape our universe.
And by doing that, he made discoveries that are still shaping our world today.
Yeah,
Technology, everything. It's amazing.
I know. It really makes you wonder what other applications of his work are still out there waiting to be discovered, right?
It really does. That's the beauty of science, isn't it? There's always more to learn, more to explore, more to find out. So as we're wrapping up this deep dive into the life and work of Louis Néel, I want to leave you with a question to think about. Imagine our world without Néel's contributions. What would your life look like without the technology that his work made possible?
That's a really interesting question to consider. It's hard to even imagine our world without his discoveries. They were that fundamental.
Exactly.
Yeah.
We take so much for granted, but it's important to remember the people who made these advancements possible. People like Néel, who dedicated their lives to expanding our knowledge. Wow, this has been an incredible journey exploring the life and work of Louis Néel.
It really has.
Who knew magnetism could be so fascinating
Yeah.
and so important to, well, basically everything around us?
You know, what strikes me is how Neil was able to take these really theoretical physics concepts and turn them into something with real-world applications. His work wasn't just stuck in some lab, it actually had an impact on tech, warfare, even how we understand our planet's history.
Yeah, that's so true. I guess just goes to show how powerful scientific curiosity can be, right? Sometimes the biggest discoveries come from just wanting to learn more about the world around us. And then those discoveries can lead to some pretty amazing things we never could have imagined, just like what we saw with Neil's work.
Absolutely. And I think that's a really great lesson for everyone listening, Never underestimate the power of asking questions and being curious. I mean, think about it. The world is full of mysteries just waiting to be solved. And who knows, maybe someone listening to this right now will be the next one to make a groundbreaking discovery.
Maybe the next Nobel Prize winner is out there listening to us right now and getting inspired. That would be so awesome.
It would.
But even if you don't end up winning a Nobel Prize, just being curious and exploring the world around you is a pretty amazing reward in itself, right?
Oh, yeah. It's all about that joy of discovery, that thrill when you finally understand something new, and then the possibility that maybe, just maybe, you can use that knowledge to make the world a little bit better.
That's beautifully said. And that brings us to the end of our deep dive into the amazing world of Louis Néel. I hope you all enjoyed exploring his life and his incredible discoveries. What a legacy.
It's been a real pleasure joining you for this one.
And all our listeners out there, remember, keep exploring. Keep asking questions and never stop learning. Thanks for tuning in to The Deep Dive.